Hello friends, welcome to aimstoday YouTube channel. In this video, we are going to discuss about IIT-JEE NEET Foundation Chemistry Atomic Structure chapter from this the phenomenon of photoelectric effect. In 1887, Hedge performed a very interesting experiment in which electrons were ejected when certain metals were exposed to a beam of light. This phenomenon is called photoelectric effect. Suppose this is a beam of metal with electrons on its surface. When a beam of light is made to fall on it, electrons are ejected by the metal surface. This phenomenon is called as photoelectric effect. This process is also often referred to as photoemission, and these ejected electrons are called photoelectrons. In terms of their behavior and their properties, photoelectrons are no different from other electrons. The prefix photo simply tells us that the electrons have been ejected from a metal surface by incident light. Here, photo represents light. So, the ejection of electrons from the metal surface by the effect of light is called as photoelectric effect. The results observed in this experiment are the electrons are ejected from the clean metal surface as soon as the beam of light strikes the surface. That means there is no time lag between the striking of light beam and the ejection of electrons from the metal surface. These two occur simultaneously. The number of electrons ejected is proportional to the intensity or brightness of the light. For each metal, there is a characteristic minimum frequency below which photoelectric effect is not observed. At a frequency, the ejected electrons come out with a certain kinetic energy. The kinetic energies of these electrons increase with the increase of frequency of the light used. If the striking photon has energy equal to h nu and the minimum energy required to eject the electrons is h nu naught, then the difference in the energy is transferred as the kinetic energy of the photoelectrons. So following conservation of energy principle, the kinetic energy of the ejected electron is given by the equation E is h nu naught, h nu is equal to h nu naught plus half m square, where h nu is the energy of the incident light and h nu naught is the work function or threshold energy of the metal, and here half m square is the kinetic energy of the ejected electron, where me is the mass of the electron and v is the velocity associated with the ejected electron. Here we can note that cesium is the best metal in photoelectric cells as it has very less ionization energy. So as it is having very less ionization energy, with less light or less energy only, we can eject the electrons from cesium very easily. That is why cesium is best used in metal in photoelectric cells. Let us see a solid example on this photoelectric effect. Here is a given question. An ultraviolet radiation with wavelength of 250 nanometers is incident on a silver foil. What is the maximum kinetic energy of the emitted electrons? So what is given here? The energy of the radiation made to fall on the silver foil is given as 250 nanometers in terms of wavelength it is given, and the work function of silver foil also is given. Now it is asked to calculate the kinetic energy of the ejected electrons. So if you find the difference between the energy made to fall on the work function of this silver foil, the difference energy is converted as is taken as kinetic energy of these ejected electrons. So now let us see solution for this. Given work function of the silver as 6.9 into 10 to the power of minus 19 joules. And the wavelength for the ultraviolet radiation is given as 250 nanometers. If we convert these nanometers into meters, we get it as 2.5 into 10 to the power of minus 7 meters. Now, Planck's constant has been h is equal to 6.625 into 10 to the power of minus 34 joule second. And the speed of light c is equal to 3 into 10 to the power of 3 into 10 to the power of 10 meters per second. Now, to calculate energy, we have formula E is equal to hc by lambda as wavelength is given. If we substitute all the values in this, H value, C value, and the wavelength, we get the energy in as 7.95 into 10 to the power of minus 19 joules. This is the energy of the incident wave light. And we have equation E is equal to, that is energy of the light incident is equal to work function of the metal surface plus kinetic energy of the ejected electrons. So here we have to know kinetic energy. So if you write like this, kinetic energy equal to energy minus work function, we get it as 1.05 into 10 to the power minus 19 joules. So in this way, the maximum kinetic energy of the empty electrons will be 1.05 into 10 to the power of minus 19 joules. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.